Today's question is 615 plus x raised to the power of 2, that is equal to 2 raised to the power of y. Our goal is to find x and values here. Here x and y are integers. Let's see how to solve it. So this expression, here we have a constant term and these two are the x and y variables. So let's take it one side as a variable and other side as constant. So that's why I'm going to do both sides by minus x raised to the power of 2. Here x raised to the power of 2 and here x raised to the power of 2 gets cancelled. So I left 2 raised to the power of y minus x raised to the power of 2, that is equal to 615. Now observe here we have a power 2 and here we don't have power 2. So if I have power 2 in this 2 raised to the power of 5, then simply you can use this property, that is a raised to the power of 2 minus b raised to the power of 2. So we can simply write this as a plus b times a minus b. Then we can solve it easily. So that's why I'm trying to convert this term as whole raised to the power of 2. For that I'm going to do times 2 over 2 in the exponent. Now it is in the form of a raised to the power of m times n. We can write this as a raised to the power of m whole raised to the power of n. So I can write this as 2 raised to the power of y over 2 whole raised to the power of 2 minus x raised to the power of 2, that is equal to 615. Now it is in the form of a square minus b square. So we can use that properties a plus b, then a minus b. So I divide it as a product of these two terms. So that's why the 615 also I am going to divide it as a product of two terms. So that means I am going to find the factors of this 615. So what are the factors of 615? Suppose if I do with number 5, then I am going to get 123. If I do with 3, then I will get 41. So if I start with the 5, then I am going to get this. Suppose if I start with 3, then I can get 205 here. Here we need to do with the 5 because our unit digit is 5 here. So if I do with 5, then I am going to get 41. So 41 is a prime number, so we have to stop here 41. So now we can write the factors. What are the factors? 615 times 1, 205 times 3, that is another factor, 205 times 3. Then I can write 123 times 5. So I can write 123 times 5. And finally I can write 41 times 15, isn't it? So let's write 41 times 15. So these are the factors of 615. So let's take one by one. From these two terms, the plus term is the larger than subtraction term. So that's why the plus term I am going to take it as 615 and the minus term I can take it as 1. So if I add, then x gets cancelled. So I left with 2 times 2 raised to the power of y over 2, that is equal to 615 plus 1, which gives 616. So in the left hand side, when the bases are same, we can add the exponent. So it becomes 2 raised to the power of y over 2 plus 1, that is equal to 616. This is for the first factor. So same like that, if I take as a second factor 205 times 3, so I am going to write only here 205 as plus term and 3 as the minus term. So after getting x gets cancelled, so I left with 2 raised to the power of y over 2 plus 1, that is equal to 205 plus 3, which gives 208. This is for the second term. Same like that, the third term 123 times 5. So I am going to take 2 raised to the power of y over 2 plus 1, that is equal to 123 plus 5, which gives 128. This is for the third factor. And the fourth factor, 2 raised to the power of y over 2 plus 1, that is equal to 41 plus 15, which gives 59. So let's write 59. Now observe here, in the left hand side, it is in the form of 2 raised to the power of something. But is it possible to write 616 as 2 raised to the power of something? No, it is not possible. What about 208? It is also not possible. And 59 also, it is not possible to write 2 raised to the power of something, isn't it? Only this 128 is possible to write in terms of 2 raised to the power of something, that is 2 raised to the power of 7. So that's why I am considering only this third factor. Remaining 3 factors I am going to reject it here. I am not taking here. So I am taking only 2 raised to the power of y2 plus 1, that is equal to 128, that is 2 raised to the power of 7. So here now my bases are same. I can equate the exponents. So that is y over 2 plus 1, that is equal to 7. So then y over 2, that is equal to 6. Then y is 12. I got the y value as 12. Using this y, I am going to find the x value. So what is our given expression? 615 plus x raised to the power of 2, that is equal to 2 raised to the power of y. Let's substitute y as 12. So if I substitute y as 12, then 2 raised to the power of 12, the value is 4096. If I do 4096 minus 615, then I am going to get 3481. This is x raised to the power of 2 value. If you take square root on both sides, then you will get x equal to plus or minus square root of 3481. Let's go and find square root of 3481 value. The unit digit we have a 1. When we get the 1 as in our square numbers, 1 square is 1, 9 square is 81. So our unit digit is either 1 or 9. We don't know, we need to find out. After that, you need to cancel the last 2 digits. Now we have a number 34. Now I am going to find the tens digit value. This 34, the lowest square number is 25, isn't it? So which is 5 square. That means this 34 lies in between 5 square and 6 square, isn't it? So the 34 less than number which we have 25, so that is 5 square. That's why you need to write 5 as in our tens place. But we don't know the number is 51 or 59. We need to find that. For that, we need to observe is 34 nearest to the which number. So is it nearer to the 25 or 36? It is nearest to the 36. That's why we need to take the larger. In 5 and 6, 6 is a larger number. So that's why you need to take the larger number. So that's why square root of 3481, the result is 59. That means our x value is plus or minus 59. These are the x value and y value is 12.